Greetings, detectives. Mrs. McKay here, and it's time to work on Learning Target Clue 3. So this is really the second half of Lesson 2, but it was kind of a long lesson, so I broke it up into 2 learning targets, but this will be a fairly short video. So we're going to start by filling in our learning target, our clue. I can use the vertical, so write the word vertical. I can use the vertical line test to determine if a relation is a function. So make sure you've filled in those blanks. I can use the vertical line test to determine if a relation is a function. And now before we go any further, let's go ahead and do a little bit of review from what we talked about last time. We've got domain. Domain, if you remember, represents all of the x values. Remember that points are made up of an x and a y value, and the domain are all of the x values. It's also known as the independent variable. So you can write that in here. And if you remember me talking about it, I also think of the x's as the girls, and so I call them the damsels, which helps me to remember that damsels begin with D, and so does domain. Okay, the damsels. Now, the range is made up of the y values. And those are dependent variables. And I call the range the rascals, and I'll explain what I mean in just a minute about that. So the rascals are the male version, and they are they're the rascals, the Y's. All right, now let's go over back on our notes where it says a relation versus a function. Now let's read this together. A relation is the mapping between a set of input values, known as the domain, and a set of output values, known as the range. So all that means is that a relation is a collection of inputs and outputs. It's a collection of inputs and outputs, and they have something that connects them. They're in a relationship, okay? So here would be an example. Here I have x and y. This is my in and my out. And if I put in 3 and I get out 5, and I put in 4 and I put in 6, if I put in 5, I get 7. That's a relation, an input and an output. It can also be written as points, as coordinate points, and you can just write it like this. And they don't have to actually have this rule that looks like you know, that you can see right away that I'm adding to. It could be something as simple as I have a 3 and a 5, and then I have a 1 and a 7, and I have a 4 and a -8. Okay? Because it's all about something that's happening. There's an input and an output. Okay? And if you remember, our inputs are always the x values. That's our domain. And our range are our outputs, which are our y values. Those are the ranges, or the range. Okay? So in this relation, the domain is 1, 3, 4, and the range is -8, 5, 7. Okay? That's all you need for a relation. Nothing else except just to say that there is an x and there is a y. There's an input, there's an output. No other rules. Okay? Now we're going to talk about functions. Function says, though, that a function is a relation between, so it's a relation, a function is a relation, just as this is up here, between a given set of elements, meaning given between a set of the domain and a set of the range, such that for each element in the domain, there exists exactly one element in the range. And the way that we can say that in a kind of an easier way is to say, for every x, there is only That's an only one y. For every x, there is only one y. That's important. You're going to want to remember that. For every x, there is only one y. Now let me explain to you why I go with the damsels and the rascals. So if I'm saying that the damsels are the domain and they're my x's, so for every girl, she only has one boyfriend. That's what I'm saying. Every girl only has one boyfriend. If she has more than one boyfriend, if she's a two-timer and she's dating two guys, then she's in a dysfunctional relationship, and it's not a function. It's not a function at all. So every girl, every X can only have one Y that's in a relationship with it. Okay? So every girl can only have one boyfriend. The problem is that with functions, it's allowed for every Y to have more than one X. That is unfair. That is sexist, which is why I call the Ys, the range, the rascals, because they're just not very nice guys. So the damsels can only have one boyfriend, but unfortunately the Ys can have more than one X or more than one girlfriend. That's just the way it is in math, unfortunately. Not my idea of the right way to do things, which is why I call them rascals. Okay, so let's take a look at a few here. Here we have the damsels and the rascals. We have this relation of 1, 2, 2, 3, 3, 4. Now I can pair them up. So the 1 pairs with a 2, and the 2 pairs with a 3. So if these are my x's and these are my y's, the x value has 1 has a 2, and the x value 2 has 3 as its y, and the 3 pairs with a 4. So every x value has a different y value. Yes? Yes. So this is called a function. It's considered a function. Let's look at the next one. Over here we have 1 pairs with a 2, and then we have 2 pairs with 2, okay, and we have 3 pairs with 2. Now, is this a function or not? Well, let's look at the x values. 1, how many boyfriends does she have? She has 1. It's 2. How many boyfriends does 2 have? She has 1. It's 2. How many boyfriends does 3 have? She has 1 boyfriend. It's 2. The problem is that Y has 3 girlfriends, right? But remember what I said, that's why he's a rascal, and so this still counts as a function. Okay? Now let's try another one. I'll make it a different color so that we can see it better. So I've got 1 pairs with 2, and then I have 1 pairs with 4. Okay, and then I have 2 pairs with 3. What's the problem here? Well, it's right here. This little 2-timing 1, she's got 2 boyfriends. She's got a 2 and a 4 as her boyfriend, and therefore this is not a function. It's not. It's dysfunctional, not a function. So that's one way to look at functions. Always remember that for every x, there is only one y. But you can also look at the graphs of functions and decide, or graphs of relations, and decide if they're functions using the vertical line test. So here's an example. Here I have a graph of a line, this orange line. And if I take and start drawing vertical line tests, like this, vertical lines through, what should happen is that my vertical lines should only cross that orange line, my function, once. And you can see that each one only crosses it one time. If it only crosses it one time, then it's a function. And that's because each one of these points is an x, and there's only one y value. If I look up and down this line, this vertical line, which would be where the x is, I only see that it lands in one place, right here. Let's do this next one, the blue one. If I draw some vertical lines, I see again that it crosses, my vertical lines cross only in one place. So this one is a function. Since that's kind of a red color, I'll change it here. Let's try this kind of reddish graph here. Let's draw some vertical lines. And what do you notice right away? Well, you notice that my vertical lines are crossing in two places. 1, 2. 1, 2, 1, 2, 1, 2. This is not a function. And you can see that it's not because my vertical lines cross the graph in more than one place. And so that means that this x value right here that says x, let's say this graph is at x 1 3/4, it's y, this point right here would be 1 3/4, or we'll just say 2, -1. But this one up here is also at 2, and it's at 1, 2, 3. So both of these points have a 2 as its x value, which means that it can't have two different y's. All right, now let's go ahead and do some practice. Let's do some on our own, shall we? Now it's your turn. Take a look at number 1 over here in my box in the sidebar. I've got it's kind of a oval shape graph. It's green. Do the vertical line test and tell me, is it a function or is it not? Yes or no? Well, you should have drawn some vertical lines, and right away you should have noticed that you are crossing the function in more, or you're crossing the graph in more than one place, so this is not a function. All right? Try the next one. Number 2, is it a function or not a function? Well, let's draw some lines and see. Looks to me like it is. The only thing that might have confused you is that this line, as the curve goes up, it gets closer and closer and closer to the x-axis, or I'm sorry, the y-axis, but it never is straight up. It always gets closer and closer and closer. So this is a function, even though it looks like it might have the same that the x might have the same y. It doesn't. The y is just a little bit further up. The x is just a little bit further up. So now let's look at this last one. That purple vertical line. Go ahead and try it out. Is it a function? Yes or no? Well, as you did this, you probably started drawing vertical lines, and you probably noticed that the only vertical line that crosses the purple line is the actual line itself. And what happens? Let's say that this is at x equals 2. When x is 2, y can be here, 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 down here, down here. So this is not a function because basically this 2 has every boyfriend in the world possible. So this vertical line is not a function. Well, that's all that I have for today. And so really the only other thing that you need to do is write yourself a key idea. And you might want to consider the key idea right here, that for every x there is only one y. Or you might want to remember how to do the vertical line test. But write something here in this spot, and something that's going to help you remember this main idea of being able to use the vertical line test to decide if a relation is a function or not. And I'll see you in class.